Hello, my name is Prima Roman, and I'm a distributed systems engineer and MLOps specialist at Rotational Labs. I've been in the data space throughout my career and have worn a number of different hats. In the last few years, I've been mainly focused on ensuring that machine learning models actually make it into production. And I'm excited to talk to you about how you can beat ChatGPT by building your own domain-specific large language model. So as you're all aware, everyone, including the bees, are buzzing about ChatGPT and LLMs. And here's a hypothetical conversation that's going on between two bees that is not too unfamiliar of a conversation, where the bee on the left has just discovered that ChatGPT can help her write blog posts and do all sorts of cool things. And the bee on the right recognizes that this is a money-making opportunity and says that we should get somebody to build a large language model for us so that we can make big bank. And the bee on the left then says, hey, that's a great idea. Let's get the otters to build one for us. Well, meanwhile, you can see by the looks on these otters' faces that they're all in distress. So there are questions that they have in their minds that is not too unfamiliar for us as data scientists who are tasked to build these large language models, having read all the literature. So one of the concerns are, how can I build my own large language model? ChatGPT is a black box and I cannot customize it. And then, other concerns are, ChatGPT is a model that's been built on trillions of samples and we don't have enough data. How do you compete? And then also, just if you read all the underlying, algorithms that are used to build ChatGPT, it can get quite overwhelming. And so this otter on the right doesn't even know where to begin. Well, what you can do to overcome the overwhelm is first start with your goal. Take a step back. And this is something that we as data scientists tend to do, is that we get so focused on the technology itself. We're so focused on the algorithms and so focused on the models that we don't sometimes think about what the business use case is. And we really should be thinking about, having conversations with the stakeholders and really understanding the end goal, because there may be some cases where machine learning is not the solution, let alone a large language model. So first, that's what needs to be established. So let's actually take a look at a concrete example. So let's imagine that you're a data scientist that works in the customer success department at a large seafood chain restaurant. And customer complaints are being addressed way too slowly. Sometimes it takes a week or two afterwards. And the more serious complaints need to be flagged for the legal team because they require mitigation to avoid lawsuits and negative public opinion. And you're a team of few data scientists and a few customer service representatives having to serve over 85 million customers every year. I mean, obviously, maybe not as many of them are going to write reviews, but imagine just the fact that your restaurant serves that many customers means that there's going to be proportionally that many more complaints that you have to deal with. And right now, you're all drowning in dealing with these complaints. And so not thinking about that, you can pause on it for a few minutes and see, what can you do to solve this problem? And then you realize, hey, from everything that I've heard about large language models, we can analyze these social media posts and then we can bucket them into positive and negative reviews and use automation to triage them much faster. And so there you go. This is one way, where you can first just make sure that you're ensuring that you're using the business use case to drive what model you're going to use. Next, you want to design your architecture, because the model building part is a small component of a larger system, that's going to be built to address this business use case. And you want to make sure that you're aligned with your team and the stakeholders. And you also want to have a roadmap of how all of these pieces are going to come together and make sure that you're all aligned on your goals. And then you want to pay attention to your data flows and make sure that everyone's on the same page. So for example, if you look at this architecture diagram, it's a simplified version, right? Like, we're not even thinking about like what tools we're going to use, because all of that will come into play later on. But really kind of designing something at a high level is good to get started. And so you have some customer review data with labels, and then you feed this data to an LLM training application. you build you train this model, and then you store the best performing model and its associated metrics in a data store. And then you want to make sure that you have some kind of monitoring, some kind of versioning in place to compare different models, over time. And then now that you have your model, then, from the middle and the right, kind of form your production scenario where you have new customer review data coming in. And these, data is going to be coming in, in real time, and you're trying to address and triage them, as soon as possible. So you'll build a publisher that'll ingest these reviews, and then you'll take the model that you just trained, and then it'll generate inferences. So anything that it predicts as negative will go to the dispute resolution team, and then anything that it predicts as positive is going to go to the customer engagement team. And then you want to have some kind of monitoring in place, and then you use all of the these loops here as for feedback, and then so that you can then use the feedback to figure out how to iterate and make the model perform better over time. And then the other thing you want to do is, like, rather than trying to build this full-blown cutting edge solution, you want to kind of bootstrap. Right? The idea of bootstrapping is that you start small, you start with like an MVP mindset. You want to just first get something out, because more often than not, just getting something out first to try out and see how it goes, and then refining based on feedback is how you're going to get further. Because it also means that you're kind of rapidly iterating, right? So you'll build your MVP, then you get some feedback, you iterate and you refine, and you kind of do this, and then you'll wind up with a model that's successful in addressing the business use case. So how can you bootstrap your own large language models? Well, it turns out that Hugging Face has a large repository of many open source large language models, and open source models are on some level better than models like ChatGPT, because they've stood the test of time, and they've have a lot of feedback from the community, and you have a lot of developers who contributed to them over time. So if you kind of think about like if you think about comparing the number of people who have contributed to open source projects versus a closed door project like ChatGPT, you can imagine that there's been a lot of refinement in open source models. And so you have access to them, and then you can use these open source models plus transfer learning to build your own domain specific LLMs. And so before I talk about transfer learning, I want to talk briefly about like why ChatGPT has been successful. And the reason that ChatGPT has been successful is, if you think about language and say use cases that are designed around the English language, the language in general has structure. So there's a vocabulary, and then there's rules of grammar that dictate how you combine words together in a meaningful pattern to form sentences, and sentences that combine in meaningful ways to form paragraphs, and then paragraphs that combine are in a meaningful pattern to form articles and novels and things like that. And so these are patterns that machines, as you can kind of throw large machines at this data, and the algorithms have gotten sophisticated over time, and you can take advantage of the cloud infrastructure with larger machines and with better chip technology. And it's just a matter of time where it's just these models are using essentially pattern recognition to generate very believable text. And so these models that you get from Hugging Face are already pre-trained and have an understanding of the English language, for example. And the thing is that, though, as good as ChatGPT has been with a lot of generalized use cases, what you'll find is that when you have very specified use case, which say your customer review data, for example, it may not even do that well, because ChatGPT is kind of like a broad brush tool that you're applying to a use case that requires a fine tip pen. And so that's where transfer learning comes in. And transfer learning gives you that last mile, where it's basically the process of taking that broad brush and converting it into a fine tip pen that's actually specifically customized to your domain with your set of language. That's because if you think about like different types of text, text about sports versus a text about, cooking will have different word choices, and words are organized differently, and, things like that. So if you have a very specific use case in your domain, you're better off using open source models and using transfer learning to like really get, a model that's much more geared towards your domain. And so the other thing that you're able to do once you have this kind of level of control is you can use your domain knowledge and data science skills to further tune the knobs of these models to achieve the outcomes that you're looking for. So let's actually talk a little bit more about what transfer learning specifically is under the hood. So these large language models, are, essentially, sophisticated neural networks, where you have this initial input layer, and then there's a series of computations that are, happening, and then you create this like final output layer where you have these fixed, set of parameters, and you've built this equation that's then used to, to run inferences on new data. And so with transfer learning, you freeze, all of these initial layers, and you just chop off like one or a few of these output layers, and then you can essentially then take your data to create new sets of output layers. And the reason that we're freezing like the first few, several layers is because, on some level, that's all of those layers kind of constitute the learning of the language itself. But then now you're actually going and fine tuning at the very end, and updating these parameters based on the characteristics of your data source. And what this means is that you don't need as much data. What you need is your data. So you don't have to worry about renting all the space in the cloud and like running a whole bunch of machines. It's really specifically now just taking these models and training it on your data set. And then the other thing is that you also get control over the training cycles, like all the retraining. So as your data evolves, you can retrain your own domain-specific large language model and make it, even better over time. And this is something you cannot do with ChatGPT because you can control the retraining cycle. So as the nature of the data changes, you can basically control those training cycles. So in a nutshell, what are the advantages of transfer learning? There's no need to relearn parts of the problem space common to both tasks, because you already learned, these pre-trained models have already learned all the basics of the English language. And because of this, you don't need a lot of large machines and multiple machines. And so there's no need for you to be GPU poor. And also now you can also train these models on a lot less data, and specifically your domain data. And so there's no need for this trillion rows of data. And then because you control the retraining cycles and can keep, feeding it new data over time, these models are going to be less susceptible to drift. And then on top of that, these models are customized to your data set, so you can deliver even better results to your customers, which is ultimately the goal of this exercise. So now that we've talked about transfer learning, I want to kind of walk you through what we did to solve a problem for one of our clients. So their problem space essentially was to identify potential supply chain risk events from a huge collection of news articles. And these risk events are an extremely small proportion of the overall collection. So this is kind of like your needle in a haystack problem, which is a really good use case for machine learning, because imagine like people having to read all these articles, and that's a lot of articles for people to read. And so you can use machine learning to find these needles. And this kind of work for just these analysts was very labor intensive and time intensive and error prone. And so our first step at trying to address this problem was to use the traditional machine learning classifiers, and they did not work. The analysts were not satisfied with their performance because there were a lot of false positives, which wound up creating more work for them. And so what we figured is that we should try to use one of the large language models from Hugging Face that is specifically geared towards sentiment analysis, because articles that talk about risk events are generally going to have a negative sentiment, as opposed to articles that don't. And so we figured we'll take one of these large language models that have, that are specifically designed for sentiment analysis. And we experimented with 4 open source models. And out of those, the Distilbert model performed the best, and it accurately predicted 60% of the risk articles, which, is a little bit better than the coin toss. So we want to do better. And actually, so the one other thing to keep in mind is that in this case, we didn't even train that Distilbert model. It just ran inferences on a subset of the data. And so now we went ahead and trained this Distilbert model on our data set. And the result was a lot better. The trained model, accurately scored 77% of the risk events, which was a 17% improvement. And could we do better? We absolutely wanted to do better. And so what we did is we took the best performing model from the last step. So the idea with these models is that once you get like a model, you've trained a model over a few different batches, and then you'll get what is deemed to be the best performing model based on a metric. You can just there's a checkpoint, basically there's a folder, where these models are saved. And then so you can take the best model and then you apply hyperparameter tuning on that model. And after that experiment, we discovered that the model accurately predicted 97% of the risk articles and 92% of the non-risk articles. So overall, it did really well on the entire collection. And one of the things that we wanted to confirm is this model still going to perform well on a set of data where the risk articles comprise less than 1% of the articles, because that's what was going to match the real situation, because that collection that we had applied hyperparameter tuning on had a lot more risk articles. The proportion was higher than what would be expected. And even there, we found that the model accurately predicted 93% of the risk articles and 72% of the non-risk articles. And so with that, the client was pretty pleased with these results, and we decided to deploy this model into production. And so what was the ultimate outcome once this model was deployed into production? Well, first, there was a time efficiency. There was an 85% reduction in analyst time spent on article review, and the client actually wound up hiring more analysts, a point that I'm going to come back to in a little bit. Then the second thing is that after deploying this model, we had fewer errors. There's significant decrease in false positives. And then the articles that were flagged as potential risk articles were of higher quality, and they were more relevant and more current, allowing analysts to perform much better analysis and create better reports on the risk events. And then they were also able to receive these articles a lot faster, because the new scoring pipeline ran a lot faster than the previous pipelines where we had used the traditional machine learning classifiers. But more importantly than this result, what did our clients say about these results? Well, our client called the model a slam dunk. And so you see here, the Otter is very happy that it was able to deliver a really well-performing large language model, with the client being happy. And essentially, even the client was floored, and also mentioned how it changed how we do business here, which was the intended outcome. So what are the key takeaways, from, what we learned here today? It is that your domain expertise is incredibly valuable, and you should not underestimate it. And then also by applying transfer learning, you can create your own large language model. You're not at the behest of ChatGPT. And because of how transfer learning works, you don't need a trillion rows of data, and you now have the playing field is level. The ability to create large language models, exists in the hands of everyone, who's interested in trying it out. And then you've also learned that first you want to focus on the business use case and use an iterative approach to refine and develop your solution to beat overwhelm. And doing so will not only get you to a solution, but it'll also get you to a slam dunk more often than just focusing on the technology itself. Now, I want to get back to this statement here about the client having hired more analysts. You would think that because there was an 85% reduction in analyst time, that the client might be thinking to themselves, we can just get rid of some of our analysts and we can save more money, and because we don't need all these people reading all these articles anymore. But what actually happened is that because these analysts got to focus on high quality articles, they were able to produce much better reports, and the company was able to sell their solution and create new value streams that in turn increase the revenue, increase the demand, due to which they decided to hire more analysts because they needed to have more analysts coming in and meeting this demand, for business. And so this is counter to the narrative that you hear that AI is going to make people lose jobs, which has been perpetuated over time and has accelerated because of ChatGPT's wild success. But the reality is that this narrative is perpetuated because the people who push it, have a zero-sum way of thinking that is either machine learning or it's human beings, and their pie is finite. But I have seen time and time again, even before large language models, the largest benefit of using machine learning is to help make people more productive and to help them solve problems that were previously unsolvable. I mean, think about this use case where these analysts had to read so many articles and was like, they were barely getting time to really get to the best articles, right? And now that they were able to focus their time on articles that actually made sense, they were able to write better reports, the quality of their work improved, and that helped the client give their customers a highly valuable product, which in turn increased demand. And that is really how this works, is you create new value streams and you're able to solve more problems. There's always problems around that need solving, which means these new value streams in the end ultimately create more jobs. And that's what I want all of you to think about, as you build your large language models, because there are definitely a lot of use cases out there for them, that can, address, problems that have not yet been solved. And so I would say also that rather than thinking about things in zero sum, think in terms of yes and. So you can have a world where you have the ChatGPTs that can help solve general use cases, and you can also have domain-specific large language models that can help address domain-specific issues. And so with that, I would like for all of you to challenge yourself and build your own streaming large language model application. And so here's a use case where, kind of similar to that anonymized example, where you take Yelp review data and feed part of it to a Hugging Face trainer, and then take another cut of that data and ingest it using a publisher. So this is using a streaming solution because more of the data is kind of coming through in a streaming fashion, and you want to be able to address these reviews as soon as possible. And so this publisher will publish this new data to a topic, and I'll talk about topics shortly. And then you have a scoring application on the other end that, as soon as it receives new data on this topic, it will run inferences and classify these reviews as either positive or negative. And how do how can you create this application? First, we're going to create a free Ensign account. So Ensign is a product that was built by us here at Rotational Labs, and it's a next generation database designed for streaming data. And this data is stored in topics, and topics are essentially the same notion as a table in a traditional relational database, except that this streaming database solution is a lot more powerful and a lot more flexible. And so you'll create a project and a topic and API keys, and this takes less than 5 minutes, and there are a lot of starter videos that will help you get started. And then have a code repository here, so you can actually see how easy it is to just get started with like a very, very basic example of building a large language model that you can then customize and turn it into your own project, where you can either use a different model or refine this model that's there because it's really bare bones. And you can use a new data source, or you can use this model on the same data with a different use case. And you get bonus points if you use a streaming data source. And we would love for you to open a PR with your project so we can see what you did. And then we'll give you a rotational t-shirt, and we would love to feature your work on our website. And last, I want to talk to you briefly about this internal Google memo where they stated, we have no moat. And in particular, this one sentence in this article is interesting, where it says, the barrier to entry for training and experimentation has dropped from the total output of a major research organization to one person, an evening, and a beefy laptop. And guess what? When I ran that hyperparameter tuning experiment, it was me, one person, who ran it during the evening with my Mac M1 laptop. And what this really means is that your moat is your domain expertise. And with that, I conclude this presentation, and want to invite you to explore and experiment with the data. We have a lot of data examples. We have a lot of code examples on top of large language models. And if you try out building this large language model and run into any kind of issues, or if you have any questions, feel free to reach out to me.